So when I say like edge, we're really talking about almost anything at the edge, and it spans from little tiny microcontrollers. We're in wearable rings all the way up to incredibly powerful edge systems. There's a ton of resources. Not only do we have documentation on our website, we've got blogs, we've got videos. We have an Edge AI certification. It takes you through all the basics.
Everybody's heard about how much power and energy that ChatGPT and all these models take in the cloud. And what you guys are trying to do is kind of take that to what can you run on something like a ring that doesn't have to go to the cloud and back to get it to do what you need it to do.
Get better quality, better audio quality at much lower power. So you get longer battery life, you could potentially get smaller earbuds that last longer, stuff like that.
Basically making the devices smarter in a way that makes sense for those devices, and then they don't need to know everything else.
Sure.
Right? They only need to do that one thing or some small subset really well.
If you come to us as a customer, we will enable you with hardware, software, and services, the complete package for your solutions.
Welcome to Forging the Future, and I'm here today at the Consumer Electronics Show in Las Vegas, and I'm sitting down with Brandon Shibley from Edge Impulse. Welcome to the show.
Yeah, thanks for having me. I'm excited to chat with you today, and it's been a lot of fun at CES already.
You've seen a lot of cool stuff. It's only day 2, so.
I mean, I have been pretty packed at the Qualcomm booth, tons of exciting stuff there, but what I've seen around the floor is there's a ton of AI, and as always, tons of innovative products.
Well, we'll get into some of that. So tell me a little bit about Edge Impulse and what you guys do, because you were a startup.
That's right.
And
Edge Impulse is an Edge AI platform. So we're making it easy for anyone to develop and deploy machine learning models and provide them the infrastructure, the services, the ability to develop data pipelines, deployment pipelines, and things like that. And since we've been acquired by Qualcomm.
Congrats, by the way.
Yeah,
it's
been exciting. That was back April 1st. So it's been a little over 9 months.
No April's Fool's joke on that.
Yeah, fortunately. So it's been a whirlwind, and so it's really scaled up what we can do as Edge Impulse. We still are the largest Edge AI platform. We have a community of, I think we're over 300,000 developers, over 500,000 projects, and we're continuing to just grow. So now under Qualcomm, it means that we have a really powerful technology portfolio from Qualcomm to build on as well. We've had the other recent acquisition of Arduino that's been very exciting. So Qualcomm engages with some of the biggest enterprises in the world, and Arduino obviously has an incredible community as well.
They do,
and it just enables us to work up and down from like folks prototyping, building one-offs to building a product that they can scale all the way to production and incredible scale.
So your platform runs on anything from an Arduino single board computer or Uno Q, which also does have a Qualcomm on it, right?
Yeah.
All the way up to heavy hardware.
Yeah. So when I say like edge, we're really talking about almost anything at the edge, and it spans from little tiny microcontrollers. We're in wearable rings like from Ultrahuman or Aura. These
ring here,
yeah, machine learning embedded directly in the ring, all the way up to incredibly powerful edge systems. So we just announced that we have support for Qualcomm's AI 100 accelerator for inference. You can do hundreds of tops at the edge is where we're going with that. So it just means an incredible amount of inference anywhere at the edge.
What's the tops, by the way?
Yeah, tera operations per second.
Okay.
And it's a lot of operations, which for doing lots of AI is really important. That's been the race lately, is how much compute can you get for the amount of power. And for very large and powerful models, they've been running these in the cloud. But
Everybody's heard about how much power and energy that ChatGPT and all these models take in the cloud. And what you guys are trying to do is kind of take that to what can you run on something like a Ring that doesn't have to go to the cloud and back to get it to do what you need it to do. Right?
Exactly. I think this is something that a lot of folks are still learning about what, like, kind of the full breadth of AI. There are very powerful and very large models, and a lot of people would probably think they want to use the most powerful models out there, but they come at, an expense. They're going to use a lot of power. They're only available in the cloud. And a lot of times they're not really necessary. So depending on the use case, that's what I like to do. And my role is really talk to people about their use case in depth, and we can help them make the most intelligent decision for their needs. And so a lot of times a much smaller model, they could be much more resource efficient and also enable privacy, at the edge. They can run it on low power hardware with minimal latency, without the need for connectivity, without the need to, for cloud spend, and those kinds of things. So
it's basically performance plus cost, right, at the edge, and edge meaning not in the cloud.
Yeah.
So let's talk a little bit about those use cases. What are people using this for? And I get what you mean. Like, you don't need Einstein standing by to answer every question you have, right? about life or whatever, right? So these models can be very small and targeted, right?
Yeah, and just because they're small doesn't mean they can't do amazing things. But usually, when you talk about the size of the model, it's a function of like how much like variability and like breadth of application does it need to be able to support. And a lot of times if you constrain your problem space down, it means you can simplify the model you can use. It can still do amazing things, but from being able to detect like any object in the entire universe versus very particular objects that you're looking for in your application means that we can bring it down in size. So we talked about the wearable rings.
Mm-hmm.
This is one space that we're very active in, is wearable devices. We are, leading the way in low power use of machine learning. Very small models can do still very great things with sensor data. Also sensor fusion, fusing together, for example, the PPE sensors that are in these devices, or accelerometers, or temperature, or other sensors as well. And we're just, I think as an industry, we're still scratching the surface there, right? There were some things that were kind of obvious, which we've been able to apply ML to. And then on the other side, there are things that are almost non-obvious. They're like just people trying to think of use cases for AI. And what we're going toward is more of a rationalization of what are actually high value use cases where machine learning is the right solution. And there are tons of them out there, but it's just taken time. Right?
Yeah. Let's talk about some specific examples. I get like the Oura Ring doesn't need to know about politics, or, it needs to know about health and things like that. So like what are they doing on the wearables on a platform like Edge AI?
I mean,
Edge Impulse.
The thing is, a lot of these companies we work with, they're specialists in particular areas of health. Mm-hmm. So they have maybe very advanced like DSP algorithms they've developed and are patented. And then they're looking to how to actually bring those into a low power device. And that's an area we can help. A lot of times that means they still use the DSP algorithms they've developed and using them for feature extraction. And then we can use those features to, for example, classify maybe activity or types of health issues that people may be facing.
So they have a DSP that's trying to detect a certain arrhythmia or something in the heart, and they want to run it on the ring locally, something like that.
And this is something that Edge Impulse has also developed, a heart rate and heart rate variability algorithm.
HRV, which everyone's all excited about.
And we've been able to get it onto the ring. So it can run in a very low power way. And those are very useful signals to then be used for other kinds of processing, right? Like I mentioned, classification of various kinds, or maybe just some kind of anomaly detection. Like there's something unusual, we don't know what it is.
Do you have a favorite? Recent favorite?
Well, I'll be honest. My favorite part of the job is the fact that we get to work on so many different problems, and everyone is like unique and exciting and often impactful.
It doesn't have to be favorite. That's always a hard question.
Yeah.
Pick one.
No, I mean,
Pick one.
There are things that are so like hydration was an interesting one to work on. There's a company we worked with called Hydrostasis, a wearable device working in the hydration technology, and it's solving a really important problem. Especially in certain fields, you can think of like firefighters that are exposed to extreme heat, very easy to be dehydrated. Athletes and things like that. So that one's been interesting.
Yeah, I've heard like, for example, one of the issues with like police dogs is that they can get like be low hydrated or basically drop dead during the job, right?
Yeah.
And you don't even realize like what's going on, right? But they just got overheated or something like that, which you're not intending to do, but you're not aware of it. It'd be nice to get alerted. Like your dog needs to drink some water.
I love the health stuff because it's just so impactful. I think that's, there's a lot of gimmicky stuff with AI, and those are the challenging ones because, the value is sometimes a little questionable. It might be like technically interesting, but what is the outcome of that? And so I think anything that has a really impactful outcome is what I get most excited about. We do a lot in computer vision as well, a lot in the industrial space, a lot of things like defect detection with computer vision.
So they're using computer vision to detect defects on manufacturing line or just like in the field or?
Yeah, almost anywhere. A lot in manufacturing, but there's a lot like, for example, in agriculture when you're like harvesting crops. And they want to do this in the field. And, that's a very interesting environment to do that in. Usually in the manufacturing environment, you have an extremely controlled environment. Lighting, positioning, everything is totally dialed in.
So how do you do that in the field? I mean, how do they use the device?
Yeah, and this is where machine learning is actually really excellent. So a lot of the classical machine vision that was not necessarily AI was relied on a lot of this like minimizing variability. It still helps to minimize variability with machine learning. It means we can use less data and train smaller models, but machine learning thrives on lots of data. And even when there's a lot of variability, if you have it well represented in the data set, we can train models that can handle all that variability. So variability in lighting, positioning, crops have effects that vary depending on the conditions of the environment or the season or things like that. And that variability isn't necessarily indicative of defects. So you want to be able to handle all that in a good way.
What are they detecting? Like they're trying to figure out whether the fruit is ready to pick, and they're using some camera on a truck, or how?
It varies a lot. I mean, it's not my area of expertise, but there are things like, infestations from, insects, or, also like certain kinds of diseases that crops get, and they want to be able to detect those in the crop and pick those out. It might also be something as simple as like sunburn or something like that, or just rot, for whatever reason. So these are all, we can train different algorithms to do different things, obviously. And so we can look for just things that are out of the norm, or we can specifically identify types of defects with computer vision. Right?
So the edge and computer vision is there's a camera that would be running your platform and your algorithm on the camera, and it's not having to go to the internet and back and do whatever it needs to do. That's right.
I mean, these systems have to run at very high speed. They need to be very reliable because, downtime is just expensive. And a lot of times these, specifically in agriculture, connectivity is not always simple. So having it on the edge has a lot of advantages. This is an area where we've had so much activity in this visual inspection space that we've been working on our own, like product related to that. So Edge Impulse as a platform works for kind of any kind of sensor data, time series, audio, image data. and it's very versatile. You can use it in so many different applications. But visual inspection specifically, we've worked so much in that space that we are working on something more targeted to help folks like really develop and tune those algorithms specifically for inspection. So that's one of those things that's coming down the pipeline from Edge Impulse.
So if I'm a startup and I'm interested in kind of adding some Edge AI to my device or my software, I would come to Edge Impulse and get a license, or how does that work?
Yeah, it's super easy to get started because you can sign up for free and use Edge Impulse for free. Now, if you're going to do something commercially, then we certainly like to have a chat and see if we can help you out. There is an enterprise license for the use of commercially deploying models trained in Edge Impulse. We also have some enterprise features that may be useful as well, specifically if you're working with larger team and scaling up and things like that. But it's my team that works with folks on taking their, wherever they're at in their product development. Could be ideation, could be prototype stage, could be like a product that's ready to go to production. And we can consult and help out in any capacity. I mean, we have all kinds of experiences we've had from folks that are completely new to machine learning, don't understand the concepts, to working with folks that are experts in this field. And there's a particular area that they either need our help or just, they may just want to like not have to own their own infrastructure and like invest their resources into maintaining it. And they're like, your platform would be perfect for us because we take care of all the orchestration of these machine learning workloads in the cloud. We have, you don't need to reinvent the wheel here, right? We've invested tons into this space, making it great. Also, for optimizing for edge devices. So there's a lot that we can bring to the table.
And I assume a lot of resources on the website if I'm a newbie to machine learning and I want to learn more about it and I get a free license from you guys, I'm going to go to the website and
there's a ton of resources.
Yeah.
So not only do we have documentation on our website, which is pretty good, we've got blogs, we've got videos. We have an Edge AI certification. It takes you through all the basics. Also, class on Coursera on Edge AI. So those are great resources. And then even if you just sign up and go to our studio, there are walkthroughs and getting started. It's just like a wizard that will just really walk you through an initial project. So those are, there's a lot of resources there to get you started.
Am I running like on a software emulator, or do I need hardware in order to test the platform out? Like, should I get an Arduino kit or something?
Well, the thing is, we support so much hardware that if you have any kit, whether it's an Arduino device or maybe a Raspberry Pi, or even you've got Qualcomm hardware, we continue to support a broad range of different hardware. You can use that, or you can even deploy to your phone. So, for example, if you're going to train a computer vision model or an audio model, we'll give you a QR code so you can just scan that and try it out on your phone. You can also do live inference directly on the platform from the cloud, so in our studio. But, we, with Edge AI being our focus, we want to make sure you have an easy way to run it onto a device.
How long does that training take? Like I want to train the model to detect an apple versus an orange.
Yeah.
Okay.
There's a number of factors that come into play, including the size of the data set and how many epochs you want to run your training for. That's configurable. But it can be as low as, just like a couple of minutes to train a simple model, or it can be hours. If you want to train a larger computer vision model with a huge data set, then this can take more time.
Would I need like just a bunch of photos? Like I imagine, okay, here's 2 photos. It's a red apple and a nice orange. Okay, you're going to be able to tell that pretty quickly. But now it's like, well, actually, apple. There's 5,200 varieties of apple, and sometimes they're yellow, sometimes they're green, sometimes they're red, sometimes they're mottled, whatever. Oranges also. Big, little, small, whatever. But you need a lot of data in order to really, if you want to be a more like a generalist, that's an apple, that's an orange,
Exactly.
Where do you get all that from? You have to have the data yourself. I guess it's from your own business.
There's a combination of ways to approach it. So having data that's your data and it's representative of how you're going to be collecting the data is always, like an ideal place to start. But you don't necessarily have to have data already. We make it very easy to collect data, but also you can synthetically generate data now, especially image data with the great generative AI models that exist. However, you have to be aware of what the limitations of those models are. So they may not necessarily have an excellent understanding of all the variability and like different distinctions that you're looking for in your data. So oftentimes a combination of techniques is useful. And then the other thing that is often useful is data augmentation. So when you have some data, you can kind of make your data set more diverse with...
By tagging it or what?
For example, I'll take some images and then apply different lighting effects to them, or orientation changes, or cropping the images, or
top, down, bottom, side, whatever, right?
Yeah, and like also... sometimes 3D models are easy to come by, or let's say you're looking for a device that you want to be able to detect devices that you've manufactured, or you've had partners who manufacture, for example. So they may already have like CAD models and stuff, which make it pretty easy to model. That's another great way to just generate a bunch of data synthetically.
Would you feed the data into the model, or would you use the 3D model to generate like 2D images? What's the best data to train it on? Really?
Yeah. So what you want to train on is the same kind of data that you're going to use the model on at inference.
Which you're going to show it. Yeah.
Yeah. So if it's 2D images, that's what we want to train it on, and we'd want them to be representative of like the real world data. So, when you're doing modeling, you'll have a 3D modeling environment, which means that you can really see the object from any angle with different lighting and all kinds of stuff. But we'll use it to generate 2D images that are representative of the real world.
Very cool. Well, thank you for coming on the show. It's been an interesting conversation. I'm sure there's more to see. I'm looking forward to what GenPulse comes out with.
Yeah, thank you. Thank you for having me. It's been a blast.
Yeah. If you are enjoying this conversation, don't miss what's next. Subscribe to Forging the Future at softtek.com/FTF, and we'll send you our ultimate guide to Edge AI. Learn how to get started with Edge AI, how Edge AI is reshaping the business landscape, and a checklist to evaluate your Edge AI readiness. Thanks for tuning in. Subscribe now. Welcome to Forging the Future, and I'm here today at the Consumer Electronics Show and sitting down with Thomas Soderholm with Nordic Semiconductor. Hey, Thomas.
Thanks for having me.
Got to get the name close. Was it good that time?
That's good.
So tell me a little bit about Nordic and what you guys do.
Sure. So historically, Nordic was started as an ASIC design company, but we back in the late 90s, we converted into standard products. We had some really good mixed signal engineers, really good low power engineers. So we created radios for any kind of industrial applications back then. So this is 433 megahertz, 868, 915. But then we quickly realized it's easier to reach out to all of the world with a frequency that is easy to go to regulation in all different countries, and that's 2.4 gig.
Which is Wi-Fi.
Sure.
The original Wi-Fi.
Yes,
basically.
like Wi-Fi, like Bluetooth, so on. So what happened back then is that there really wasn't any good solutions out there for proprietary 2.4 gigahertz solutions. So we were one of the first ones launching that. And this was back in 2002. And ever since, we sort of built on that history, keeping our DNA with low power at the center. And we've become big in Bluetooth Low Energy. We've expanded into cellular, Wi-Fi now, and also looking at the big picture of what our customers are trying to solve. We want to also support them with power management. So we've got our own power management ICs. Also looking at other ways to help our customers get the best out of their products, really. But it's in all essence, it's a connectivity company. We're market leaders in Bluetooth Low Energy. We're all about solution. It's not about hardware, software, or services. It's about the complete package.
And so you actually co-invented, or at least co-wrote, the BLE spec, the Bluetooth Low Energy spec, right?
Correct. So back then, there really wasn't a good solution for having low power devices talk to a phone. So Nokia and Nordic at the time sort of got together and figured out, let's do something about that. And that's what later became the Bluetooth Low Energy specification. So we have a long history with Bluetooth Low Energy. We have a very strong team, probably the biggest Bluetooth Low Energy team in the world at the moment. Considered gold standard in the tech society.
Well, I know we use a lot of your products on devices that we developed,
thank you.
Definitely try to be a good partner. Is BLE, does it run at 2.4 megahertz?
Gigahertz.
Yes. Gigahertz, yes, 2.4 gigahertz. So
gigahertz,
is it the same as Wi-Fi?
Yes, and if you look at it's the same and different, right? So runs at the same 2.4 gigahertz or 2.4 gigahertz band, but Wi-Fi also runs in 5 and now 6 with Wi-Fi 6. So yes, similar and congested, so to say, right? But they're very different. In Bluetooth Low Energy is very low power. It's all about small packages, staying on the air for a short time, avoiding the congestions, right?
I actually didn't know it was the same frequency.
Oh yeah.
It hasn't been clearing up since they've been moving on to 5 and 6, or was it? I mean, is Bluetooth? I mean, or is it still pretty crowded down there?
It's crowded, but it I want to say you got to get into a really crowded scenario where shit hits the fan.
Yeah, so like CES.
So no matter what you try to do at CES, whether it's 2.4 gig BLE, Wi-Fi, or cellular even, right? It's horrible. Just sending a text message down on the floor is yeah.
Yeah, besides the Faraday cage of everything, but then everybody's doing everything all at once. I mean, we're probably getting microwaved down there. I don't know what's going on, but anyway. But no, that's pretty interesting. I think it was a game changer for BLE to come along. Of course, Bluetooth in general has had kind of a love-hate relationship with a lot of people, right? But, you know, it's been the best that we could get. Right, and I think BLE has improved on that. But you know, it's in everything now. Right? Like you said, it's de facto communication standard for devices, at least locally, right?
Yeah.
So what's new? What have you announced lately? I think you had a big announcement yesterday.
We did. So if we just step back for one moment and let's talk about what's happened over the last year or so.
Okay.
So we've developed a new family of devices for 2.4 gigahertz for BLE and 802.15.4 and so on. So we came up with a family called the NRF54 family.
NRF54.
Yeah, okay. And that's a new family of devices, and it's in 22 nanometer. And what's happened is that we've sort of created the family of devices inside of the 54 family. And yesterday we announced the latest addition to that family. It's called the NRF54 LM20B.
That's a mouthful.
What's that?
That's a mouthful.
It gets to be eventually, doesn't it?
It sounds like you guys are a bunch of engineers, not a bunch of marketers.
There you go. And you couldn't be closer to the truth, right? But what that brings to that family of devices and what we're expanding on as a company is this complete solution. The LM20B actually adds a new processor inside, so it's a huge system of application controllers and memory and ARM and RISC cores and whatnot. But it also adds this NPU. So you have this neural processing unit, which is completely designed and owned by Nordic, and is super efficient. to do edge AI solutions on very small battery-driven devices. So we're sort of bringing edge AI and machine learning, which everyone is talking about, right, to all the way to the edge, to the smallest, lowest power devices.
Interesting. So you'll be able to deploy a model to that NPU and have it do what? What are some maybe use cases that I would use that for?
So some of the here's the thing, right? Some of these use cases like sound, word recognition,
like Alexa,
or just image recognition. Some of these things you can do on our other devices as well. What this new processor brings to the picture is just doing it much more efficient, both processing-wise and power-wise.
So when you say it's low power, how low power? I mean, is it something that's going to work on a wearable, a ring, or whatever?
Exactly. So those are great examples, right? So you can imagine sort of gesture recognition in a ring or a wearable, or word recognition in the same kind of setting, like a watch. And if you look at it from that perspective, we've also acquired a company last summer called Newton AI, which builds really small and power efficient models for AI. And these models can run on our even smallest 2.4 gig devices. So really it's all part of this road we're on to get more of the machine learning and AI to the edge, for the reason that once it stays on your device at the edge, it's not only more private and secure, but you're saving power because you're sending less data and so on, right? So we really want to enable our customers to do more on our devices, and by that saving power. Going back to the Nordic sort of low power DNA.
So it'd be gesture recognition possibly, or
Yes.
How is Meta doing like the gestures that they're using on their Meta glasses? I mean, I think do they have a wristband or something like that? And then it's like picking up some signals or...
Exactly the details I don't know, but they have a wristband that they use for that. I've seen people do it in wristband watches, rings even, right? So moving, I guess, from that perspective, moving a little bit away from controllers you hold, whether it's a remote control or VR controllers or whatnot, you can do a lot of that gesture recognition in smaller wearable devices.
I think some people have the impression when you say AI at the edge, it means like basically doing everything that something like ChatGPT does on the device, but it's not true, right?
No, that's not true.
So the cases are like gesturing or wake words or, I don't know, health data that you're trying to like monitor and trying to analyze sound. Maybe like you want to muffle a gunshot or something, so you want to detect a gunshot and like muffle it instantly and then unmute it or something. I don't know, things like that.
And it can be health related. It can be heart rate models.
Arrhythmias and
exactly right. Yeah.
Interesting. Do you have any favorites that you've seen that this can do or detect on the edge?
Haven't seen anything yet. I think the jury's still out, right? Like I said, we just announced this hardware yesterday. What I've seen sort of so far, whether it's our customers or others in the edge AI space, there's like toothbrushes helping you to ensure you brush your teeth correctly and stuff like that. That's pretty cool.
That's interesting. So instead of just timing, hey, you brushed for 2 minutes.
Exactly.
But you did a lousy job brushing for 2 minutes, right?
Or it'll guide you, right? So you should do that side.
You missed the left side.
Yeah.
You've missed that tooth 3 times in a row now. You might want to get back there. That's interesting. Yeah, basically making the devices smarter in a way that makes sense for those devices, and then they don't need to know everything else.
Sure.
Right? They only need to do that one thing or some small subset really, really well. Right? What about the training part of it? I mean, how do you I mean, it sounds cool. I've got this chip, this NPU on a Nordic device, and how do I use it?
So we've also, together with the Newton models we have and the new hardware we launched yesterday, we have a software. So we have a Nordic Edge AI Lab, which we also launched, which will help guide and enable our customers to very easily generate their own models, program the hardware, gather the data, and so on. So yeah, everything be enabled by Nordic products and technology.
Interesting.
Yeah.
Do you see, moving forward, like with BLE? I mean, what's kind of next for BLE? Is there BLE? I don't know, 8.0 or wherever it's at now.
So we're at 6.
6, yeah. Okay. What's 8 look like? That's what I want to know.
Yeah. No, you and me both, right?
Yeah, right.
But I think if you sort of look at it historically, right? So what's happened with BLE, like I said, initially it was a need to have low power battery-driven devices, small battery-driven devices talk to a phone. Whether it be like a heart rate belt or a asset tracking, sort of find my tag or whatever, right? So that's sort of, if you did that with classic Bluetooth, you'd kill the battery. So that's where BLE started. But if you sort of look at the history from when BLE started to where we are now, a lot's happened to cover more area. So one big one has been LE Audio and Auracast, where LE Audio has proven that you can get better quality at much lower power than the classic Bluetooth audio standard with BLE. So unfortunately, the market hasn't, or some of the big, let's say, contenders in the space haven't moved completely to that technology yet. So it's taking time for the whole ecosystem to change. But it's stuff like that, right? So if you envision Bluetooth Low Energy in the future, you can imagine them wanting to, or the Bluetooth SIG wanting to take up more and more market by covering more and more technology, so to say, right?
Do they call it BLE Audio or is it BLE?
LE Audio.
LE Audio, right? Yeah.
Yeah,
so.
and part of that is Auracast, which is the broadcast side of it, which is actually taking off.
Right. You just need some of the big guys to go ahead and support it, right? Yeah. So you need the Apples and Googles of the world to.
Well, you need the phones. As soon as here's the thing. They support it to a certain degree today, right? Because they support Bluetooth Low Energy. But it really, if LE Audio is going to take off completely, you need the big mobile phone manufacturers to turn off classic audio and just say, if you want to do audio, it has to be LE Audio.
So what's the advantage of the consumer of old Bluetooth audio versus LE Audio?
Well, the advantage for the consumer with LE Audio versus classic is power consumption and quality. You get better quality, better audio quality at much lower power. So you get longer battery life. You could potentially get smaller earbuds that last longer, stuff like that, right?
And why do you think they're holding off on adoption?
I don't want to presume anything there. I don't want to make anyone mad.
That. Yeah. Okay. All right. Fair enough. Who can peer into the mind of Tim Cook? Right?
Yeah.
All right. Well, that's interesting, and it's significant savings, right? I mean, your phone is pretty good at streaming and playing audio now, but I mean, it does still drain your battery, right?
Sure.
Where in my AirPods, they do last only a few hours, right? Usually, before you have to. They're pretty efficient, but if they could be even more, because they die in the middle of a call that you really want to be on, right? So,
but it's not on the phone side necessarily that the benefit is, because that's a big battery, so to say. It's on all the smaller devices like the AirPods and whatnot.
Oh, I see, right?
Yeah.
So
that's where the huge benefit is.
The phone has to support it because it's communicating to the device, but the benefits are going to be on the longer lasting battery on the device.
And you can imagine something like you have a lot of these wearables now that support music, So you can download your Spotify playlist to your smartwatch. And today, if you wanna connect to a headset, that needs to be classic Bluetooth. Why? Because the headset is classic Bluetooth, right? And the headset's not gonna go away from classic Bluetooth until the phone goes away from classic Bluetooth. So
Nirvana would be the iPhone and the AirPods both supporting LE audio, and then we're going.
And then everyone else is going to go in that direction, I'm sure.
Well, they always need new features. I mean, iPhone 18 maybe that'll be a feature. Who knows, right?
Could be.
So obviously you're pioneers in Bluetooth and BLE, but you guys do a lot of other things, right? So maybe tell me a little bit about what else you do.
Sure. So we've really expanded from BLE into both cellular and Wi-Fi. So staying on the connectivity side of things. So we have a very low power cellular solution now for small battery driven devices. We have a low power Wi-Fi solution as well. If you sort of look at where we're going with the company, you can imagine that's the direction where we have more connectivity standards that cover a broader selection of technology opportunities. But also the fact that we look at the complete picture for our customers. So it's important for us to ensure that our customer has the best performance from the battery to the antenna. So with that, you have power management ICs, which we now have in our portfolio. We also look at how can we enable and support our customers for the lifetime of their products, not just during development. So we have our own cloud services. So this cloud lifecycle service program, where we support observability, locationing, and so on and so forth, ensuring that if you come to us as a customer, we will enable you with hardware, software, and services, the complete package for your solutions.
Plus partners like Softtech, right?
Exactly, and great. Thank you for reminding me. So there are certain things we don't do, and we rely on partners. So we have a partner program where we're talking to Softtech. Obviously, we have customers coming to us asking for specific help to specific problems that we don't offer, and then we do rely on partners.
Sure.
So yeah.
Well, Thomas, that's super exciting. I agree. Sexy. Definitely looking forward to seeing more devices support things like NTN. Non-terrestrial network sounds very sci-fi, spacey, etc. So thanks for coming on the show and sharing what Nordic is doing to forge the future.
Thanks for having me.
If you found this conversation useful, make sure to like and subscribe to Forging the Future wherever you listen. Join the 40,000 plus subscribers to our monthly newsletter, Edge of Tech, for more insights at the intersection of technology and innovation. And if you want to stay connected between episodes, follow Softtech and Forging the Future on LinkedIn for clips, insights, and behind-the-scenes conversations. Check the show notes for all these links. Keep forging the future, and we'll see you next time.